Hello, ladies and gentlemen. So today I'm going to take a few minutes to go through the example problem having to do with testing. Again, this was assigned to you, and I'm assuming that some of you did fine on it, but some of you are looking for a little more information. So let's get started. I chose to, or generally choose to, start off by figuring out what is my goal, what is my objective. And you'll excuse me, but I read through it and it says, I want to maximize my score. Okay, well, that's my objective, that's my target. Now I'm going to go through and I'm going to look and see where do we talk about awarding score points. And it says up at the top that computational problems are worth 6 points and word problems are worth 10 points. Now I'm going to take that information to construct my objective function, but I'm also going to say, well, wait a second here. I also need to figure out what my variable is. So if you notice, we're doing everything in terms of computational versus word, computational problems versus word, and I can say, okay, that's a pretty good indicator that I'm looking at those as my variables. So I'm going to say that x equals the number of computational. It would help if I could write faster, but I can't. Okay, no idea why it's acting so strangely. Okay. And I'm also going to say that I'm looking for my y to be the number of word problems. Okay. And again, I apologize, my chicken scratch handwriting is not being helped by this lovely electronic device. So what can we do then in terms of the objective function? Now, I'm going to say that I get my points from number of computational problems times 6 points, because I get 6 points for every computational problem, and my word problems give me 10. So what I'm going to do now is I'm going to go down to the objective function line, and I'm going to say that 6x plus 10y is going to get me my total number of points. Now, if I choose to, I could say, well, that's going to equal, I don't know, p for points. You don't have to, but it's an equality. And that's something that I want to emphasize is the difference between the objective function and the constraints is your objective function is always an equality. Okay, so again, I'm just taking 6 times the number of computational problems because I get 6 points for every one of the computational problems, and hopefully that makes sense. All right, next up, let's take a look at trying to come up with my constraints here. And how would I go about doing that? Well, let's see. I've got some sort of limitation, and that's where I'm going to emphasize my time. It says that I have 40 minutes to take the test, which means I have a limitation of time. So now I'm going to be looking for other information that tells me about the time. Well, it says that my computational problems take 2 minutes and my word problems take 4 minutes. Okay, if that's the case, then how do I go about actually figuring out where things go? Well, I'm going to say that if I take, let's go back here, 2 times the number of computational problems plus 4 times the number of word problems, I know that that total has to be less than 40 minutes. Now, it doesn't have to be 40 minutes, but I have to be done with the test by 40 minutes. Okay, so far so good. Next, let's check and see if I have any other limitations as I'm reading through this. It says that I may answer no more than 12 problems. So that means I am at most going to be using taking 12 problems. So I can say, well, again, remembering that I've got my two variables, again, x and y being computational and word problems. So I'm just going to say that I'm going to say that the sum of these two when I add up the number of problems that I've answered, that has to be less than or equal to 12, which gets me another constraint. Okay, next up, I also kind of have to fall back on one of these things that's always kind of hidden in there. We're going to say, can you answer a negative number of problems? You're going to say no, so I'm going to say x has to be greater than 0 and y has to be greater than 0. And that is my set of constraints. Now, if at any point in time you need to redo or take another look at this, again, feel free. That's why it's uploaded to YouTube. But I am also going to say that at this point, we're going to switch gears and we're going to jump into Desmos so you can actually graph it. So what I'm going to do is I'm going to enter those 4 equations into Desmos. Now, again, desmos.com is fine. In this case, I'm going to emphasize that you want to have this little keyboard here available because that's the only way you're going to be able to get your greater than or equal to or less than or equal to. So I'm going to use my given constraints and I'm going to say, okay, that was 2x plus 4y. And I'm going to go down here and say that's going to be less than or equal to, I believe it was 40. And then I'm going to add on an additional equation by clicking on this. And I'm going to say that x plus y has to be, again, less than or equal to 12 questions. Okay, and I'm also going to do the inequality where I say that x is greater than 0, and I'm going to add in that y must be greater than 0. Now, close this one up so you can actually see the screen, and what I am looking at is this shaded region in here. That gives me my feasible region. That's going to get me what I need. So at this point, I'm now going to say I need to find the corners of my feasible region. Down here, that looks like it is a corner, so I'm going to click on it. And you will see that it pulls up what the value is. That's 0, 0. Okay, next I'm going to go up here because this is another corner of the feasible region, and I can say that that is going to be 1, 10. Next, I'm looking at this one, which I've already got, and again, I can click, that's going to get me 4, 8. And then finally, I'm looking at this corner down here, which is going to get me 12, 0. Okay, so these are the 4 corners that I need to make sure that I'm using in order to determine my max or my min. So I've got my 4 corners. Let me go back to my work here and see what I can do. So let's go in here and see what I can do about scrolling down. Again, if you want to, you could take a screenshot of this. So let me go back into Desmos for a second because I'm sure some of you would like to do that. And I'll just take a screenshot of this section in here. And then I could, in theory at least, paste this onto that there, and unfortunately because of the formatting on this it's not going to be as happy, but I can go back and look at it. So graph I don't need you to show me, but I do need you to go through and actually evaluate P at my 4 points. So I'm going to say P at 0, 0, P at 0, 10. Again, this is just the number of points. P at 4, 8, and P at 12, 0. And at this point, I'm just going to sub these in to my 2 variables here, my x and my y. So when I sub in 0, 0, that's going to be pretty easy. I'm going to get 0, 0. Next, my total points when I only do 10 word problems, that's going to get me 10 times 10, which is 100. Okay. Then this next one, I'm going to show a little more work on. I'm going to have 6 times 4 and 10 times 8. So I'm now looking at, that's going to be 24 plus 80 or 108. Okay, I'm sorry, that's 104. Wow, shameful, shameful. Okay, 104. Okay, got it. All right, and then finally, we're going to sub in 12 and 0. And what I end up with there is I'm going to say, well, 12 times 6 is just going to get me 72. So again, my goal is to maximize my score. And all I need to do is compare my 4 scores. And when I compare my 4 scores, I hope it's fairly clear that this is my maximum. So I'm going to say I'm going to do 4 computational problems and I'm going to do 8 word problems. All right. Now, that's my answer to this. Of course, if I asked you to minimize it, you would be saying, well, that's not that difficult. All I need to do is find where my minimum value is for my objective. Okay? Hoping that this helps, and I will look forward to seeing you in class. All right? Take care, have fun, and good luck.